It's really important to thoroughly understand the application. So we would start by reviewing the statement of work or application information that the customer provides, and then we would have a consultative meeting with the customer to make sure that we really understand how they intend the system to function and that we understand all the nuances that are associated with that. My favorite part of the design process is got to be the conceptual phase. We'll typically come up with several design concepts that would theoretically meet the customer's application. And in a lot of cases we'll do maybe two more traditional approaches, and then we will try to think outside of the box and think of a non-traditional solution to the customer's application. Well, one comes to mind. We have an application not large in scale, but difficult in complexity. Customer needed to move a sample in 2 degrees of rotation, and then they needed to be able to cut the sample. And the most important thing in that application was that the holder needed to be rigid as a solid block when cutting, but it also still needed to be able to affect the actuation. So it was very challenging, and the solution we came up with was a unique mechanism to be able to lock the moving portions of the frame together, such that during cutting it was essentially one solid piece, but then unlock it and allow it to move in the motion it required. So although it was a relatively simple application, it was very challenging to actually design the mechanism to do that. I don't know if I'd call it a secret, but I think probably the most overlooked part of it is manufacturability. So engineers focus on the concept and then on the design and making sure that it meets the specifications. And often it's overlooked until you design the prototype how you're going to be able to make all the components, whether you're going to be able to make all the components economically. Whereas if that was considered a little bit more earlier in the design phase, you might not have to go through the design for manufacturability at a later time. Well, the founder of the company, Bob Bloom, once told me, he said, if you can't measure it, then you can't build it. And I've taken that to heart, and over the years we've put in the test equipment, measuring equipment, laser interferometer, large-scale CMMs, helium leak detectors. I mean, these are all really important pieces of equipment. When you're doing an application that requires testing, you've got to have the right equipment for the job, and we have always made it a point to acquire and have that equipment for the applications. We tend to do a lot of medical applications. It's been very gratifying to work on an application from the conceptual phase through the prototype phase and then see the equipment actually get out into the field and be used for patients. To see something that you've had a hand or some portion in designing and worked on actually developing it and manufacturing it, that's really gratifying. I think it's a fact that we're large enough to have the resources, the depth of engineering team, the equipment that we just discussed, but we're small enough to give personal attention to the customer and make them feel like we are part of their engineering team. I think that's really important, because I think if you go to some of these larger design houses, you're just one project in 100, literally, and that's not the way it is here. We're small enough that we can still give personal individual attention to the customer.